Action.
Oh, shit.
Duct insulation. At 15 degrees Fahrenheit temperature, difference from the inside to the outside of the duct is considered the maximum difference allowed before insulation is necessary. Metal duct can be insulated on the outside and on the inside. The insulation is joined by taping it, stapling it, and tapping it.
Okay, so
Tap that shit.
that's a picture of a guy insulating metal duct, wrapping it.
Mm-hmm.
Okay, so what's the cutoff temperature before you need to do that?
15 degrees.
15 degrees.
Fahrenheit. Not Reagan.
You can insulate it on the inside. This is called black insulation. It's cut and glued on the inside, and it's also, it can be used by, you can use pin spotters to hold it in place too. The only problem with that is if you have a 20 by 20 duct and you put 1 inch insulation in there, what size duct do you have now?
16, 16.
18 by 18. Yeah, so you've decreased the size, so you have to compensate for that by making, when you make the duct. Okay. Pretty simple, really, right?
Blending the conditioned air with room air. Air should be directed into the walls. The diffuser spreads the air to the desired air pattern. Place diffusers next to the outside walls. How far the air will be blown from the diffuser into the room depends on the air pressure behind the diffuser and the style of the diffuser blades.
The return air duct system. Invalid return air system will give the most positive return air. The return air duct is normally sized slightly larger than the supply duct. A path must be provided for the air to return to the central return. The return air grill should be around an elbow from the furnace.
Okay, the word is individual. So individual. Individual returns are gonna provide the most positive air return. Like this, it's usually around an elbow. This is a commercial unit. So they're gonna put an elbow, if you're gonna return all the air in the attic, let's say, they're always gonna put an elbow on that. Just for the noise factor. So it helps to eliminate the unit noise. Ooh, another picture. This is an attic. AC in the attic, then return, the back, you get supply. Isn't that exciting? Okay, pictures. Okay. Here we have a typical house with a basement. And it's showing the return is coming from the, it doesn't show it, it's right here. So the return is on the top, or on the main floor, and the air that pushed down into the basement is drawn up through the staircase and into the return.
Sizing ducts for moving air. Friction loss in ductwork. Due to the rubbing action of the air against the side of the duct and the turbulence of the air while moving down the duct, the smoother the duct's interior surface is and the slower the air is moving, the less friction there will be. Each foot of duct offers a known resistance to airflow.
Okay.
Measuring air movement for balancing. Air balancing is accomplished by measuring the air level of each register. Measuring velocity of the duct in a cross-section of the duct. Determine the CFM by using the formula CFM equals area in square feet times velocity in feet per minute.
Okay, so this is in the book. An example that's in the book, right?
They use it, Marshall.
Yeah. 1129. There it is. Okay, so what they're doing and what they're saying is if you can measure the velocity of that duct, the air in that duct, you can figure out what the cubic feet per minute is. Okay? So in this case here, it's an 18 by 8 inch duct. That equals 144 square inches. Each measurement they take, they're gonna take 6 measurements on this duct. Each measurement is written down. It's added up and divided by how many measurements were taken. You get the velocity, get the total velocity of that duct, because air doesn't travel down the duct at the same rate in each spot. You can see one is 80 feet per minute, and you got 5 down here, it's giving you 120 feet per minute. So each area of those ducts, you have to take multiple readings on that duct because of that, and get an average to figure out what the velocity is. Velocity is measured in feet per minute. Cubic feet per minute, or CFM, is the volume of the air, and feet per minute is the speed of the air. Different things. So you can increase the velocity and not increase the CFM, or the volume. That makes sense? It's awful quiet in here. Wow.
There's a real science behind this,
Yes.
what I'm noticing.
Well said. So it's actually taking, so the formula is, what is it? Velocity times cross-sectional area, which is 144 square inches, at 100 feet per minute, which is 100 feet, times 1 square foot equals 100 CFM. So how many of you know that 144 square inches is 1 square foot? You know that now?
144 square inches, you said?
Yeah, what's 12 by 12? So when you're dealing in inches, you gotta convert it to feet for this formula. So it's actually a foot, square foot. So you guys know about this?
Oh, yeah, I did that already.
Pi r squared? You ever heard that before?
Yeah.
Okay. You know that's wrong, don't you?
Why is it wrong?
Why is it wrong?
Because pi r not squared, pi r round.
Oh.
But, gee.
Okay. That's all.
Okay, so, and because we're gonna need to figure out on round ducts sometimes, we're gonna have to figure out the square footage. Right?
Yeah.
Okay, so if this round duct is from here to here is the radius, right?
No, diameter.
Radius?
No, radius, diameter is all the way. Radius,
Diameter would be all the way,
The
Yeah.
full, yeah.
diameter. And circumference would be all the way around, right?
Right.
Correct.
smart. So your radius is 14 inches.
44.0426.
Okay, so if you have 14 inch, the radius is 14, and pi is what? 3.14.
14,
1.4.
5, 9.
146.
Yeah.
Let's go 146. And squared, so radius times 14 is, or pi times 14 is what?
44.0426.
44?
Yes. 44.0426.
Okay.
0, 4.
1. 44.1.
There you go.
Okay.
Numbers.
So you gotta square that? Right? So what is 44 squared? Squared 44?
1,944.80.
I got 1,139.
1,000.
Are you sure it's, you don't? 14.14
No.
1,944.81.
1944?
Yeah, 0.81.
4.
0.81.
Where? Then 1945.
Okay, so that's square inches, so we gotta convert it to square feet, right? So we're gonna divide it by what?
Well,
What?
12.
Nope, nope. Square inches to foot, square foot.
144.
144. You forgot, huh?
You're kinda smart, Marshall.
144.
I just make it good. 13.5.
Huh?
13.5.
13.5?
Yeah.
13.5 square feet,
Boom.
okay? Kinda get an idea how that works?
Yeah.
A little bit? Yeah? Okay. You got it?
Yeah.
You don't got it.
You answered too fast. So it was 13.5? 13.5, right? Square feet?
No worries.
So our velocity is, say it's 700? 700 feet per minute? What's our CFM?
9450.
Huh?
9,450.
9,460?
50.
1,450.
5.
50.
50. 9450 CFM.
Yes.
We're on CFM. So we can figure out the CFM out of that ductwork. Our ductwork is gonna be sized according to CFM. In case you didn't know that. But we need to know what CFM is required, we need to know what CFM is. So a lot of times, we're not gonna be able to get the CFM until we get the velocity. And we might have to do this. So, what the guy is doing right there, he's taking measurements, and he's taking 6 measurements this way, and 6 measurements that way. So 6 times 6 is how many? 36. So he's gonna take 36 measurements of air, and that's just a pitot tube that's going in there. So he's taking it all the way to the far side of the duct through this hole, and he's pulling it out a little bit, and he's taking a reading, and he does that 6 times. Each time he pulls it out, he measures the distance between these two dots, and he pulls it out and measures, pulls it out and measures, pulls it out, measures, pulls it out, measures. And then he goes to the next hole and does the same thing, so every square inch of that duct has got a reading. Or every 2 or 3 square. That's the only way to get an average of velocity on a closed up duct system. Here's a picture of one right here. Isn't that exciting? That's exciting. Yes, you have to drill holes in the duct.
Where do you think you're going, Victor?
Where are you going?
I'll be back.
We're in the middle of lecture.
That's free.
I'd never.
Never, I gotta go.
Okay. Who we got here? Who we got?
Air friction chart. Used by system designers to size ductwork and duct systems. Gives recommended duct sizes and velocities for optimum performance. Used to troubleshoot airflow problems. Pressure drops in duct fittings have equivalent length. All length and equivalent lengths are added together to achieve the total.
Okay. Where's the thing in here? Right here in the middle. What does it say?
Used to
Used to troubleshoot airflow problems.
Troubleshoot. There's that word.
Oh,
What
that's
you're here
something in our
for.
job description.
Troubleshooting, right? So, who'd have ever thought you were gonna troubleshoot airflow problems?
Yeah, it is, but.
Okay. There's the air friction chart. Isn't that exciting?
Is that kinda what we were playing with last week?
No.
Oh.
So, on the air friction chart, obviously down at the bottom is the static pressure that's in water column. So those are vertical lines, are gonna go up. And as you cross this required CFM for each area, you're gonna cross those 2 lines, right? And they're gonna come to a point, ground zero again. And from that point on, you can get your velocity, and you can get make sure your static pressure is within the area, and it's also gonna give you the duct size. The required duct size for that velocity and that static pressure and that cubic feet per minute. Isn't that exciting?
I love these charts.
This is how you're gonna size ducts. Oh, there's that word again. Check it out. That's what you're here for, right? Troubleshooting.
Practical troubleshooting technique. Most duct systems are either residential or commercial installations. Most tests of residential systems is performed at the register and grills. Commercial systems will require the use of instruments.
Okay, so, here we go. There's some problems. There's some problems right there. What are,
Accessibility and flexible duct lines.
Disconnected duct runs, close dampers, was it collapsed?
flexible?
Flex ducts, loose installations in the duct, block grills and/or registers.
Okay, so all these are they're pretty common problems. We got some pictures here. Can we see a problem there?
Yeah, the duct is
Not even hooked up, huh?
yeah.
It came apart right here. Wow.
What could cause that problem?
Raccoon.
A mouse jumping on it.
That's true.
The squirrel
It's like-
can't find the squirrel cage.
Somebody kicked it. It's like it's in an attic. Okay. Here's 2 of the other problems, right?
So when it's damp,
insulation on it. We're gonna have a problem with that, in that attic, right? Versus it's 160 degrees in that attic, and you got 75-degree air in there. What about over here? Huh? Yeah. Isn't that nice? That's a return. It's a return air depth. And once the unit's on, there's no way to fix that, because it's just gonna suck in like that. Yeah? So, you need to replace that entire depth. What's that? Isn't that exciting?
Leak.
Huh?
Looks like a leak.
Yeah, looks like a lot of leaks, huh? Yeah, no insulation?
Looks like ground beef.
Ground.
Is that it? Next slide. Yeah. Yeah.
Commercial duct systems. Each area has specifications regarding this required amount of airflow. Certified testing and balancing company should verify airflow. Flow hoods measure air volume at supply registers. Total airflow is measured at the main duct. Common problems include dirty filters, partially closed dampers, and incorrect fan rotation.
Okay, so there's some more problems, huh? Dirty filters, would that be a problem
Yes.
with airflow? Closed dampers? Yeah, you never know until you actually check the damper and see if it's closed or. Another problem we're seeing a lot of times is what they call, there's a fire damper in the ductwork. And the time the ductwork goes across the firewall, it has to have a fire damper. So a lot of times those things just get old and shut. So that's gonna cause a problem in that duct, right? See that? What is that thing?
Is that thing?
What? That thing over there, what, wood chipper?
Yeah.
Okay, so a wood chipper is used to check airflow on a, like, that one particular, right there is, fits on a T-bar ceiling, so it'll fit right around those 2x2 squares. Isn't that exciting? We'll get to use it too.
In this class?
Yeah,
Oh, cool.
we have one.
Well, doesn't mean you let us use it.
I'm calling you out, Steve.
Right? I'm not wrong.
She's wrong.
Hey, man, sad. Feels good.
What does it say?
It says summary, forced air systems use the same air over and over. Fresh air enters the structure by infiltration. Forced air systems deliver the correct quality of continued air to the occupied space. Different spaces require different air qualities. Forced air systems are made up of the blower, supply duct system, return air system, and supply registers or grills. Typically, 400 CFMs of air must be moved per minute per ton of air conditioning. Pressure in the ductwork is measured in inches of water column in WC. Static pressure plus velocity pressure equals total pressure. Air volume in CFM can be calculated by multiplying the air velocity by the cross-sectional area of the duct in square feet. Propeller fans are used in exhaust fans and condenser fans applications and can handle large volumes of air at low pressure differential. Centrifugal blowers are used in duct systems. Motors drives can be directed or belt-driven assemblies. Can't put lights on that, okay. The supply duct system can be configured as a lunum,
Madam,
lunum,
Madam.
extended lunum, reducing extended, yeah, or pre-meter loop system.
Perimeter.
Shut up, if I had an accent, you guys wouldn't be correcting me. Duct system can be made of galvanized metal, aluminum, fiberglass, duct, board, spiral matter, flexible duct, or a combination of different materials. Just trying to get that one. Branch duct delivers the proper amount of air to remote locations in the structure. Balancing dampers are used to help ensure proper air flow to the remote location.
Summary,
Thank you, God.
the return air system can be configured as a central or individual return air system. Friction in the duct slows the airflow in it. Slower air experience less friction. Summary continues. Air balancing ensures the proper amount of air is delivered to each supply register. CFM equals velocity times cross-sectional area. The friction chart is used to properly size duct system.
I'll read the next.
Good job, everybody.
good job.